I did not switch. Okay, I did not switch it off.
Okay.
Oh, we have to keep track on that.
Yeah.
Shall we start, Marc?
Yeah, shall we do that?
Yeah.
Right. So welcome everyone. Welcome to this special session about the adoption of technical supportive innovations. We have 4 nice speakers, 4 nice presentations in our session today. So I want to welcome Barrie Dams of University of Bath, John van Oorschot of the Zuid University of Applied Sciences. He is also a co-chair of today's session.
Welcome.
And the third session would be from Pelle Munch-Petersen, together with Mikkel Thomassen. I hope I pronounce it correctly. They are from the Royal Danish Academy of Fine Arts. And then the fourth session would be by David Pons of the Mangosuthu University of Technology. Also a difficult name to pronounce. My name is Marc van den Berg, by the way. I'm an assistant professor at the University of Twente. And I will also be chairing this session together with John, as I just mentioned. So we will be listening to 4 presentations. Starting with the one from Barrie Dams, and I'm going to ask the speakers to turn on their webcams when they are presenting, and keep the webcams off when they are not presenting. The questions and answer session, that's at the end of all the presentations. So after all presentations are finished, we have a debate with all the speakers. So to the members in the audience, I'm inviting you to actively participate in this session, and you can do that by asking your questions in the chat. So just type your message in the chat if you want to ask something to one of the speakers. Would be most practical if you also put the name of the presenter to which you want to ask a question. So write down who you want to ask something, and then we can have the discussion and the questions later on. So those are some announcements up front. John, would you like to add something, or shall we?
Yeah, some small issues for the newcomers. On the low right corner there is an icon. I would advise you to use the full screen mode of this the full screen setting of this for this presentation. That's the best way to attend the presentations. Yeah, I wish you all a very nice session, of course.
Yes, also on my behalf. So let's start with the first presentation then. If you like, I give you a signal when you have about 1 minute left. All right?
Okay.
So then the floor is yours, Barrie.
Okay, so hopefully you're able to see my presentation.
Yes, you can see it.
So you can see that first slide. Excellent. So good afternoon, everyone. My name's Barrie Dams. I'm from the University of Bath in the UK, and I'll be speaking today on the challenges in upscaling non-residential bio-based circular construction. So I'm part of a large project called the Circular Bio-Based Construction Industry, funded by Interreg and involving lots of partner institutions in Belgium and the Netherlands, France and the UK, including the University of Bath. I'm involved in lots of different aspects of the project, including circular design, building physics, but today I'll be talking about some interviews that were conducted last year with professionals who have been involved in bio-based buildings. So construction and the circular economy. Of course, the circular economy striving to eliminate waste and reuse or recycle source materials, in stark contrast to the all too familiar linear economy, where we take something, make something, and then dispose of it after we've finished using it. In the context of construction, construction in a circular or sustainable manner can be considered as reusing or recycling materials, or rearranging or modifying or expanding buildings after their first design life. So bio-based materials are suitable for circular construction. They're renewable when sustainably managed. You can have a negative carbon footprint, as the material can sequester carbon. The material can be recycled, reducing in a demand for source material. It might be able to be composted, even if it cannot be reused or recycled. And in addition to that, you've got the building physics properties of the materials. You've got acoustic properties, hygroscopic properties, the ability to absorb and desorb moisture from the air, thus regulating internal environments and making the environments more comfortable for the user. Okay, so a brief overview of a few UK case studies of bio-based buildings. Adnams Distribution Centre, completed in 2006 in the east of England. This uses hemp-lime blocks to regulate the internal environment and keep it at a suitable temperature and relative humidity for their stored product. The building also uses glulam beams and a sedum roof, both of which were the largest in the UK. And the building can be expanded in the future as well. Okay, we have the British Museum Science Store. This is a storage facility contained on an older World War II airfield site in the west of England, in Wroughton near Swindon. This is another hemp-lime building with also some other bio-based features as well. This was actually constructed inside an existing concrete aircraft hangar. And again, the purpose of the hemp lime is to attenuate fluctuations in relative humidity, so to help look after and preserve the stored objects and paper archives. And the Enterprise Centre as well, the University of East Anglia. This was built using lots of local materials and using local crafts and trades. It was really designed to regenerate the local economy, and also to have a long design life of 100 years, and to use as many locally sourced products as possible, such as thatch and timber. So interviews have been conducted throughout the project partners, and so I conducted several interviews myself in the UK last year with professionals involved in these case studies. And basically I'll be dividing up roughly the sort of issues into three broad categories: finance, knowledge and policy. And one sort of overbearing thing that we kept coming back to was cost. There are sort of lots of trade-offs, it seems, but one particular one that comes to cost. You've got high initial cost and you're balancing that against long-term economic savings. So I will go through now looking at the challenges for finance, knowledge and policy. So these are the sort of key findings. There are others, but these are obviously the sort of core ones. So as mentioned, high initial cost of materials. Unfortunately, contractors, they usually sort of look to value engineer sustainable objectives out of projects on the grounds of cost as well. Economic viability needs to run throughout the supply chain. Growing non-food crops needs to be profitable for local farmers. The issue of upscaling materials, a lot of money can be spent on research, but then obviously for new manufacturers starting up, it can be very expensive to upscale your business, to have research done to gain certification and accreditation. And of course, you've got the financial power of existing companies used to working with perhaps concrete and steel, who may want to maintain things as they are. Challenges with knowledge. There is debate as to what is the most effective dissemination method for existing studies. It seems to be generally agreed that there still aren't enough case studies, and case studies are very valuable in disseminating the benefits of using bio-based materials, both in terms of building physics and long-term economics. There are existing databases of previous studies, but again, these need to be maintained and promoted. People need to be aware of them. There is debate on where does the responsibility for knowledge lie: the client, the contractor, the consultant, or all three. And of course, the need for each project to have a champion, a member of senior personnel who is able to drive the project forward and argue convincingly for it economically as well as in terms of knowledge. And the challenges with policy, of course, construction may not necessarily be at the top of governmental agendas. For example, market regulation in a free economy is another issue. If legislation is to be involved, is it punitive? Are there going to be taxes involved or bans? Is it going to involve incentives, for example, loans or grants for using particular bio-based materials, as there can be issues involved with both? So just having a look at some avenues for the way forward. In terms of finance, a big thing is obviously the long-term savings that companies can make with bio-based buildings. It has to be a long-term perspective so that high initial costs will be clawed back over a long period in terms of energy savings. Improving occupant wellness, for example, a company could have a higher workforce morale and productivity, lower absenteeism and turnover. Again, that is a benefit to the company over a long period of time, and of course to the user as well of the building. Financial incentives for sustainable construction, perhaps. And another avenue is new stakeholders with an emerging product looking to work with and collaborate with existing stakeholders rather than as competition and trying to compete with established big companies. Opportunities for knowledge, for example, look at disseminating knowledge to construction industry professionals. The most effective way of doing that, perhaps encouraging certification such as Passive House certification and keeping that refreshed and renewed and ongoing, and looking at modern methods of construction and promoting dry methods of construction using dry mechanical connections, gravity and interlocking connections rather than wet chemical connections to promote the building being able to be reused or disassembled or adapted after the first design life. And also promoting case studies and showing that you can build houses from these materials, not just high-end premium projects. And in terms of policy, for example, using natural materials might help with green belt planning applications. For example, having biological materials such as a sort of grass or facade or straw would be more sympathetic to natural environments. Looking to boost regional economies, looking to boost local businesses, local landowners and farm owners to grow non-food crops, looking to boost local trades and keep local trades and crafts alive. Regional regeneration could be a big argument in the case for bio-based circular construction. Looking at on the governmental level, making construction a key part of tackling climate change, and obviously the climate summits that are going on and the zero carbon targets, making construction a big part of that. Localizing construction, so growing crops locally so we don't have to import materials from all over the world, encourage local materials and local use, and localized construction. And of course, perhaps financial incentives and subsidies for new emerging products to help establish and upscale them. So to conclude, key conclusions. So upscaling of circular bio-based construction is certainly required to reduce the carbon footprint of construction. Policy is required both at national and regional levels to drive forward bio-based circular construction. Key challenges: high initial costs, opposition possibly within client organizations, lack of knowledge, risk elements making contractors uneasy, and of course how high construction is on governmental policy agendas. Opportunities all the way forward, looking at positive legislation, promoting long-term economic cases so that people are aware of the long-term economic potential benefits, promoting the wellness agenda, having a happy, a well user and occupant of the building, regenerating local economies and local businesses. And what is certainly required is the increase in promotion of case studies and accreditation of materials so that people, professionals, have the confidence to work with these materials moving forwards and are aware of the benefits. I believe my time is up, so I would like to thank you very much for listening to my presentation. Thank you very much.
Thank you very much, Barrie. Nice in time. As I mentioned before, we directly proceed with the next presentation and keep the questions for later on. So I would like to invite my co-chair, John van Oorschot, to proceed with his presentation.
Yes, I believe my screen is visible for everyone from
Yes.
this point on. Yeah, great. Well, thank you for the opportunity to present also my research here today. Yeah, my name is John van Oorschot, and I will present my work about modularity as a strategy to sustain the development and adoption of circular building technologies. And I will do that based on our experiences in the Superlocal project. So we start developing some new circular building technologies, but what about the next projects? How do we get these technologies adopted beyond the Superlocal project? Well, I'm part of the my research conducted as being part of the Smart Urban Redesign Research Center, which I'm a senior researcher, and we try to combine three research lines about circular building technology, sustainable energy in the built environment, and urban and transformation. And how this materializes, I think you can very nicely see that in this in our Superlocal project. Within the Superlocal project, we are responsible for actually the monitoring part of the project, being very critical about and providing the critical reflections about, yeah, what we are doing, is this really circular? What are we achieving here? And the findings what I'm presenting here today are part of our experiences in this project. Well, I like to share many pictures, and this is my first picture. It's a nice rooftop picture of the three apartment buildings. And well, you can find many in Limburg, but I think also across the Netherlands and beyond. This housing, these big building blocks were constructed in a period of housing shortage, and provided housing for per building block for about 100 families. Typically, during the days, there was a high social cohesion, and actually on the galleries, well, people has a kind of community sense, a street feeling, and they really lived in that way. Also on the balconies, or if they were in their front or back garden. However, over time, well, the communities living there face growing social and economic problems. Well, after closing the mines and also the condition of the buildings, were bad, and at some point even some technical issues emerged. The balconies are no longer safe. And also because of the changing demographics in that region, well, these buildings became obsolete, and for that reason it was decided to demolish them. And well, in that area, in that region, it was decided to conduct various circular experiments to keep as much of the value pertaining to these apartment buildings in that specific region. And I'm not going to address all the circular experiments we conducted, but one of the key experiments was to make new housing out of these big apartment blocks, just only by using these available materials. Well, most part of the most significant material available from these building blocks is of course concrete, but also insulation material, wood, or some other types of materials, masonry, which we try to reuse in building new housing. As a starting point, it is something different. In many circular building projects, well, we start from the beginning, new build projects, and it's all about extracting and introducing new materials in the process. But our starting point was something different. We start by desampling buildings and using these materials to construct new ones. So that's really most different than from very notable examples of circular buildings across the Netherlands, which are of course also very nice examples, but have a different starting point as relative to our projects. As a strategy, and also with the idea that we want to create a real impact beyond this project, we use also the concept of modularity to sustain not only the development of circular building technologies, but has also have the opportunity to get these technologies adopted beyond this particular project. And it is framed as a key strategy to boost the circular transition, according to the Ellen MacArthur Foundation. And we already see that modular products are they are growing in number, but as with the new buildings, also starting often from virgin materials. What we try to study further, what we do research in this project is we want to get real impact, but the impact of the application of modular products on the transition to our circular house building has still to be fully developed. As mentioned, concrete is the material we have surplus if we're gonna demolish these apartment buildings. So what we developed is 5 concrete scenarios in which we try to reuse parts of these structures available, and they have different levels of modularity. So modularity is not it's something you can approach at different levels. So it's actually a kind of scale. So what we did, we used entire compartments. So we cut out parts of the building as a base for the new housing. You could also cut out slabs that are 2D concrete elements for building new housing. What we also did is we used the concrete as aggregates in making new concrete, but then we make prefab elements out of it. You can do it in that way, or as in scenario 4, just do it on site in pouring new concrete elements. And what we also did is try to make smaller elements. We call them we baptize them as bricks, to sustain more traditional way of building and add some flexibility to the process. And this is actually what we implemented.
1 more minute, John.
Yeah, this is what we implemented in 3 subsequent stages of the project. We had the first trial, then we did a small experiment with 3 housing, and eventually we had this implemented in 15 row houses. So what we did, we want to calculate the real impact of this way of constructing these houses. And what we first did was to calculate what did we gain from it in terms of environmental impact. And we calculated if you for the 5 scenarios what the embodied energy and the embodied carbon is. And from this we learned if you use the big elements in a repetitive way, it has a really severe lower environmental impact than traditional construction if you do it with traditional concrete. That's the yellow bar in the first row. And the same applies for 2D slabs. While the other options are more or less, are resulting in the same environmental impact as traditional construction. Well, this is one point. If you try to approach from a different way, you want to try to calculate cost, then there is a different scenario. Well, if you try to implement this, we learned already that implementing the slabs was not possible because of structural integrity problems. We could not materialize that in the project. The same applies for the bricks because it took much more development time to apply them to develop them in such a way that we could apply them in the project. So my final slide, it's about the costs. Well, if you look at the first bar, it's in a traditional way of constructing these housing units. You see that it's still much more cheaper than reusing parts of the existing apartment buildings. Well, in the extreme, using the entire apartment units as the base for the building, well, it's triple or even 4 times more expensive than do it in a traditional way. It's going up to over 80,000 euros only for the bare structure. Knowing that if you construct these housing units in a traditional way, the total cost for the entire buildings is up to 100,000, 25,000 euros. So, and then even if we try to optimize it for 20 to 50 units, that's the 4th bar, you see there is only a very small, there is a cost reduction, but it's not coming close to even to the traditional construction. And this is the reason for that is that it's so labor intensive to get these units out that it's not a very promising technique at this point. If you try to calculate this with and compare them with traditional economic models. So for this reason, we need to balance this in the new future and try to improve these technology in a different way to make them more economic viable. And at least we can learn from this what the limitations are for constructing apartment buildings in a traditional way, as we have done in the which was done in the superlocal apartment buildings. So there is some limitations building in this way. That's something at least we can learn from this project. So design for this assembly is essential in this aspect. Very briefly, any questions? I look for them in the chat.
All right, thank you, John. Thanks for sharing your insights. We quickly proceed with Mikkel Thomassen and Pelle Munch-Petersen with their presentation. So please go ahead, the floor is yours.
Well, thank you so much. I think I could say on behalf of both of us, Pelle. And I think this presentation, like the 2 preceding presentations, is about how to upscale circularity. So I think that's a very consistent line in our presentation this afternoon session. Perhaps the theoretical perspective will be slightly different, as you'll see. Anyway, thanks also to our the persons or organization founding this research project, the Dania and Grønlands Investeringsfond, to Danish Foundation that is supporting the research project which this presentation is part of. So what we like to argue in our presentation is that perhaps construction is a bit troubled by what you could call the electric kitchen knife syndrome. That because we had a perceived idea about a lot of materials that was available, a lot of technologies that were available, we produced something very complex, very technical advanced, even though that we could have stayed with much simpler solutions like the Japanese kitchen knife. So perhaps what problems we have been having, and that is very much in line with the presentation we had this morning at 10 o'clock by Iris Stitt, we have had this idea that we have an abundance of materials at our disposal, and due to that we were quite lazy with respect to our designs of buildings. So what we like to argue in this paper, in this conceptual paper, is that in order to close the one-way ticket of material use in construction into a circular one, we need to replace simple problem solving, creating very complex buildings with much more advanced problem solving that will allow us to have simpler buildings in the sense of buildings with less material use, less double function, and so forth. So the discussion we're having in this paper, and it is really a cross-disciplinary paper, Pelle comes with a background in an architect and I come with a background in economics, is what happens if we conceive circularity not so much as something that has to do with material flows and physical property of the world, but something that also has to do with circularity as knowledge, the intangible aspects of circularity. So we address circularity as an information issue, as an information problem, you might say, from partly an architectural perspective. what is the potential in the tectonics of avoidance, as we call it, and what is, secondly, the barriers to this tectonics of avoidance that I will address later on in an economic perspective. So I'll give the floor to you, Pelle, and to address the first part of this very short talk.
Thank you, Mikkel. So I'll introduce the concept of tectonics of avoidance, which is basically, you can say, an architectural reaction to the new agenda in sustainability and, of course, circular economy. Basically, it stands on the idea that before we talk about reduce, reuse, and recycle, something comes actually before that. And if we look at the historic waste hierarchy, they often call this prevention or avoidance. So what we can see once we dive into the circular economy and the new ideas of sustainability is that there is actually a connecting idea about this stuff that we could and maybe should avoid. And when this is employed into architecture, it ends up becoming two different strategies, where one of them we've divided into two. And a lot of it you've heard a lot about already today. So here's just a really quick run through. And basically, Tectonics of Avoidance 1A and 1B is about the materials in architecture. And we talk a lot about the materials, and of course, both the materials in form of its hard resources, which could lead to scarcity when we overuse, and then of course what we can call soft resources, well, the impacts of our material choices and the embedded energy and so forth. Here's an example of one that takes Tectonics of Avoidance A upon itself, and the A is basically a strategy that goes towards bringing down the impacts on construction right now. So it looks at the beginning phases of an LCA and say, okay, we have to build renewable materials, simple construction, less layered, all of it should be renewable or low impact, if not reused. So the strategy here is to say, okay, once we erect something, the impact of this will be very low and it will be made from resources that we can reproduce. The second part of this is, of course, and this is, the weak point in an LCA, is that it talks about a distant future that we know basically nothing about. So what can we do to separate the lifespan of materials from the lifespan of buildings? And here, of course, we've heard a lot of great things today about design for disassembly, where we here have on the left side the bad ones, the adhesives, the cast-in, the welded solution, and on the right side we have the quick-release, friction-based and bolted solutions. So basically trying to find ways that whatever we combine and whatever architectural compositions we make, they will be able to take them apart and be reused in other things. So that's the simple version. And then, of course, we have the more complex version, which has also been discussed today. And that is basically our ideas about human well-being and more practically the indoor environment strategy of modern design, and especially office buildings. Here in front of you, you have Baumschlager Ebelis 2226, and this is a building without heating or cooling or mechanical ventilation. All it needs is basically people showing up for work, and you have enough energy combined with the sun. So what you are ending up with is a very easy to understand tectonics of avoidance, because all of these unnecessary systems are identified and taken out. So there are no suspended ceilings, there are no dynamic solar shading, there are no tech flooring, there are no shafts, and so on. So there are these 2/3 different categories of tectonics of avoidance that we have investigated. And what we've come to, basically, which Mikkel will elaborate on now, is that this is not a complicated design. It leads to very, very simple solutions, very much like the Japanese knife. But to do this in a practical architectural setting, at least in Denmark, is very, very difficult. The lack of knowledge and the order in ways design unfolds has to change dramatically in order to do this. And now back to you, Mikkel.
Yes, thank you, Pelle. I think one of the surprising facts about circular economy is that there's a lot of talk about circularity, but not a lot of thought about economics, you might say, and at least not a lot of economic theory behind circular economy. So let me try to put a bit of economic thoughts into the concept of circular economy and build on the example you just concluded on, Pelle. Because what is, I think, really striking when you see the Baumschlager Ebelis building is that it's not the materials or the products. They're pretty straightforward, and as you say, Pelle, quite simple actually. What is really striking about the Barnes building is all the intellectual property rights, so to speak, all the information in processing leading to it, all the design efforts made by Barnes. So to understand a building like that and a circular solution like that is not to understand the market for products, but to understand the market for information. So I think we know the way ahead. What we need to understand is, will this kind of circular solutions come around if it's all about a market not for products, but a market for information? And or in another, to put it differently, how will this innovation of nothingness, this innovation of not adding layers and adding materials, but removing layers and removing materials, will this come around by itself in a market-driven economy? And we're quite skeptical that this will happen for the reason given now. Because information is, as pointed out by Kenneth Arrow, one of the leading grounding fathers of the informational economics, information is not really a nice commodity, you might say. It doesn't work the same way as the market for you, for instance. Because on one hand, we'd like information to be free, because there's no additional cost for another one using information. So if you have it, you should share it freely in order to have the maximum impact. But on the other hand, we would like information to be owned, because otherwise no one will invest in generating this new kind of information. So what we see is,
wrap up.
Yeah. So what we see is there will be a downward basis to devote resources to invention if it cannot be put into products. From a firm perspective, from an individual perspective, it will not pay to put innovation into information only if it cannot be productized. So even though this strategy of Tectonics of avoidance is so compelling from a sustainable point of view, from an overall societal point of view, it is not very likely that it will come around in a market-driven economy. There might be a few ways to go around that, and I'll not have time to dig into this. There can be some strategies for that. Barnes could turn into a turnkey contractor, turn to the dark force, you might say, or they might become a YouTuber, tapping into the digital economy, and so on and so on. And I'm just kind of raising these two stupid examples to come up with our general point that I think what we learned from the first part of this presentation, or what we've been trying to argue, is that we need to think more in order to build less. But in order for this to happen, and as I've been trying to argue very briefly, we need to think about how we make it attractive to invest in knowledge. So to understand how we make circular resources flows, we need to understand the flow of information and incentives. Yeah, that's basically it. Thank you.
Okay, great. Thank you very much. So then we directly proceed to the last presentation of today. And the last presentation is given by David Pons. So David, are you there? Yes.
Good.
Yes, so please go ahead.
Great. Thank you very much. And this is an innovation that we've been developing in South Africa, obviously for low-cost houses over here. So in this particular country, we have a thing called a tokoloshi, and I'm sure you've got some sort of things in Holland that you're scared of. But this particular guy, if you have a square house or a square room and you're going to trap him in the corner, he's going to cause a lot of trouble. So what happened in the past is they made lovely Zulu culture huts out of thatch and grass, which was fantastic. And the culture that we speak about is actually Zulu king, and he passed away last week. So we have different changes in tradition, and he held up tradition. Yeah. Part of the tradition of cows are wealth. It's an indication of your wealth, and of course, to marry someone, you're going to have to buy a lot of cows and give it across to the other family. All well-being, but overgrazing occurs over here, and then because of the overgrazing, the grass gets eaten and the buildings get changed. So they change slowly but surely. people didn't understand that the thatch and the grass was actually an insulation. So they make tin shacks, tin houses, and because there's a high crime area or theft in these particular areas, they have very small windows and burglar bars, and so they have a very, very stifled room that they sleep inside. So they also have dark colors. They don't understand really that the heat is increasing in the house, and we have a lot of sun here in Africa, and so the people live very, very uncomfortably. A university, I could have said a building picture, but here's some of the students. That's a typical class. We have about 100 in our class, and we have some projects. And this is a university project that I'm referring about. The university project that we have is called sealing in a can, and it's a solution. So it's a two-part polymer that's mixed together to create a sealing. Prior to that, we've got to find out what exactly is the problem. And the problem really is transporting of a conventional sealing to your particular house. So we also have odd-shaped buildings where it's difficult to measure the size. We have no tools, and we have people with limited skills, and we still need to find some form of insulation sealing for these particular people. Of course, everyone wants they like a sealing, more for status. They don't really understand insulation. And of course, it's very, very hot in summer, and it's very cold in the winter months. And we all understand the insulation. So how do we do it? We remove the furniture from the particular houses. We mix 2 cans of the chemical together. We cover the floor with newspaper. We spread out the sealing in a can mixture evenly. We wait 15 minutes for foaming and setting. You can walk on the foam. You can free the corners with a knife. And then you start at the door and you lift it up and you attach it to the rafters using a chipboard sealing. And if you want to, you can remove the paper afterwards. So obviously I can do a video, but it's not capable over here. And it attaches with chipboard screws. And you end up with a sealing that's insulating in a very small room in a small area over here. So the result is, of course, jobs for the shack dwellers or people who live in shack dwellers, profits for the hardware shops, and also better living for the particular people that we have. So the benefit is we're trying to make an insulated ceiling in 20 minutes, and to transport the ceiling, you can transport it in. The top picture is the mode of transport most people use in South Africa, and the bottom picture is conventional sealing, which is very difficult. It saves electricity, and of course, this innovation is half the cost of a conventional gypsum board sealing over here. So the trend of people are choosing to live close to the city. They're moving to the city. They're living in these tin houses, and so there's a growing market for people to renovate their particular houses like this. How to scale? Well, it's very difficult to scale because there's so many shacks in South Africa. There are 5 million shacks, and there are many shacks all over the world in developing countries that probably need an innovation like this over here. So it's a competitive advantage over the other processes of sealings over there. It reduces the household electricity. It's better living conditions. It's waterproof. It's also fire retardant. Obviously, lightweight installation is very easy, and your transport is easy, and your cost is the best benefit we have over here. So the shack dwellers don't have tape measures. They don't have tools. They also have no windows, and so they also have asbestos roofs. So this is also going to stop the asbestos dust from falling on the particular people. And the better living conditions are also possible with cooler temperatures. It has a social impact, better living, and inhabitants are also more proud of their house because they've got these particular ceilings, and it's also health mitigation. And the main thing, of course, is it also creates jobs for people to install these particular ceilings over here. Financial result is a profitable, sustainable business. You don't need any government, and it's also is a business for people to install the particular ceiling. So there are a whole lot of shortfalls over here. It's brand activation. It's difficult. It's a very strange concept for consumers to make a ceiling on the floor and then lift it up to the roof. Very difficult to educate the people. Like we've had 2 generations that haven't lived in a thatch or straw house, and so the heat is, they don't understand insulation. And it's a difficult to run a business for a university, and in a particular university that we have. Around houses, very difficult. If they're still building them, they use sticks on the inside, and basically those are failed particular plans over there. So the training of the people is also difficult to do, to train people how to install these particular ceilings. The next step is we're going to raise funds for commercialization. We're going to roll it out of South Africa, and obviously try and get it into other parts of the particular world that we have. Ceiling in a can it uses a technology, and we're trying to make better living for people. Thank you very much.
All right, thank you very much, David, for your presentation. So right now I would like to invite all the other speakers as well to turn on their webcams, and we can have a discussion about all the interesting presentations that you just gave us. So a couple of questions came in from the audience, so I propose we just go through them one by one. But the speakers can, of course, also just jump in if they have some questions to one of the other speakers, and also the members of the audience can also still pose any questions in the chat. So I will have a look at that again. So first of all, I need to scroll a little bit back. Starting with a small side question to Barrie about the green roof that you showed in case study 1. How often does it need to be maintained?
Oscar, to my knowledge, it has not had to be. I don't think anything in particular has to be done to it. I don't know how often it is inspected, but because obviously our main focus from Bath was on the hemp lime aspect. But I do know that the company are very happy with it, and it certainly does not cause them any ongoing maintenance issues. But in terms of whether it gets an annual inspection, I'm not entirely sure. But from what I sort of gathered in the interview, there have been no maintenance issues with it, and they've been very sort of happy with the performance. And obviously, they've got a rainwater harvesting system as well, which helps to provide some of the water for the building. So yes, yeah. I hope that answers the question. But in terms of whether they need an annual inspection, I'm not 100% sure.
Yeah. All right. Another question from the same person. It was about the framework. Did you have a look at the framework to bring in different stakeholders together and streamline the different construction projects?
Of a framework,
I think this refers to a cost issue.
Right. So in terms of in terms of like whether the project has developed a framework, in terms of what the project is doing on the whole with regards to interviews, is that it's looking to sort of gather as much information on experiences as possible, and looking to produce white papers to obviously, I suppose, sort of help to form a framework for circular construction, to make construction industry professionals aware of the benefits of using the materials. And there are sort of specialist teams dealing with elements such as procurement, looking at different methods of education and sort of competences, and looking at sort of rules and regulations and the sort of role that policymakers can play. So I think that the overall aim of the project is to produce white papers which enable policymakers to be able to perhaps introduce a framework for circular construction. In terms of the interviews that we did in the UK, it was really more a case of understanding the sort of current issues and looking for sort of ways forward and how we can contribute to that, as there could be sort of different situations in the different countries involved on the project. But yes, I think that's certainly an aim of the project, is to try and facilitate and get perhaps hopefully an internationally recognized framework to help, particularly with procurement, particularly with public sector procurement in using these types of materials. I hope that answers your question.
Right, I hope so too. So the next question is actually from another speaker. So perhaps I just give the word to David to ask his question about the gap between research and innovation. David, would you like to ask his question?
Yeah, thanks. It's crazy. It's quite sad that there's so many people from universities here. But once you get an innovation, or once people are working on research, how do you actually get that commercialized in terms of an innovation where you're actually starting to sell and produce something? Are there any shortcuts, tips, or things like that?
Yeah, I mean, I've from the interviews that I did, that seems to be one of the biggest challenges in facing an innovator when you've got a new idea or a new material and you're trying to start up. One particular interviewee spoke about how a new product that they've got, where basically they have a policy of both looking to universities with which to collaborate and obviously do the testing, so that obviously accreditation can happen and certification, so you can get certain performances in terms of mechanical properties and fire resistance, that sort of thing. But also having an approach of looking at collaborating with existing larger companies who perhaps work with maybe sort of non-biomaterial, so approaching someone who traditionally deals with concrete or steel and look at some sort of collaboration with them rather than trying to compete with them. Because as a new company starting up, a new small company competing with large established companies, I'm sure is incredibly challenging, if not borderline impossible. So look at some sort of approach of collaboration with existing companies that is of mutual benefit, so that the product can be advanced, it can be upscaled, perhaps manufactured, but a large existing company can financially share in the reward as well, so that the new product is not viewed as competition. It becomes part of their operation. So I think a policy of collaboration might be a way forward for a new manufacturer, in addition to working with universities and getting the research done to get accreditation for the material.
Right. Any Danish additions?
Yeah, I would like to add a bit on that. I think, to me, the main problem is very often not the gap between research and companies, but more the gap between startup companies working in niche markets and then more established companies working in large-scale markets. I think that is where the major gap very often is. And I think one of the problems is perhaps that we have this tendency within construction, having a background within architecture, design, and engineering. We're so concerned with developing the solutions, but we're not so concerned with putting our creativity into the financial models by which these solutions should be provided. And what we try to argue in our paper is that for some of the most interesting circular solutions, there's no incentive whatsoever from a firm perspective to engage in them, because you can't protect these open source kind of innovation. So it's not because they don't want it, but there's simply no incentives. So we have to address also these financial aspects, not by the end of the day, but from the outset, I think.
Mm-hmm. Okay, thank you. Let's have a look at the next question from Omid. Thank you. This was also posed to Barrie, I believe. So thank you for sharing your experiences. And do you also think that the reusing materials that are not designed and built for reuse is the way to move to a circular built environment? Can you reflect on that?
Right. Yes. So in terms of I think probably largely referring perhaps to concrete and steel, possibly. So I think as concrete is very difficult. So in terms of whether concrete has a future with circularity, you would, I guess, sort of look at sort of precast and sort of off-site modular construction using concrete. In terms of in situ created concrete and existing buildings, yeah, I mean, obviously, it's a huge challenge to sort of reuse the materials there. In terms of steel, even though it's still very much in the minority in the UK, structural steel members can be reused in terms of the mechanical properties. I can only think that it's on the grounds of cost that it is easier and cheaper to either recycle or demolish or dispose than it is to test, assess, and reuse. So that's probably the main contributor as to why, certainly in the UK, reusing structural steel members after the design life of a building isn't more common practice. So I think that definitely does have a future in circular construction, but it needs It needs a policy change. It needs legislation. Something needs to happen financially in order for that to become a normal standard thing. Yes. So I hope that answers your question. But yes, I think in terms of concrete, and concrete isn't going anywhere. Concrete has to be worked with, I think, because in terms of a global scale, we've got to look at using concrete because bio-based materials, although I hope there is a bright future for them, and I believe there is, they're going to be working alongside established materials, and concrete is certainly here to stay on a global scale for the foreseeable future. So I think sort of looking at the design and prefabrication and construction is the way forward with using concrete in a circular manner.
Okay. Pelle?
Yeah, I would just like to add to that, because I think sometimes when we look at circular construction, we seem to think that stuff moves on its own in a circular economy. And I think we see a lot of examples of that, at least in Denmark, that we reuse materials, and by doing so we emit more CO2 and propel more material than looking for a simpler solution of maybe virgin materials. So we end up using more material of a different category and end up putting more CO2 into the atmosphere by reusing material than looking critically at both the soft and the hard resources as we looked at them. So I think we always have to look at, if we're talking about materials that are not designed for disassembly and not designed to be reused, and talking about how to reuse them, we have to be very, very critical about what the impacts of doing so are. And if we make sure that we can find something around the corner that is just much more sustainable. So we have to remind ourselves that nothing moves on its own, and not even in a circular economy.
Right. Thank you. John, the case example that you gave us was also not designed and built for disassembly. So what's your take on this?
Well, yeah, thank you for this question. Well, what we actually really learned is the impact of the structures we already have today, and which are also still constructed today, and what the impact is for the future generations. So actually, if you are able to reuse them, you see a much lower environmental impact, and there is also from a cost perspective, if you try to reuse these buildings, not built to be able to easily disassembled, it's very costly, and then for that it's not interesting anymore for reusing these type of structures. So you're creating really a problem for future generations. And at this point, the best solution seems to be to really to reuse the structures as they are. Well, of course, we try to do that in the super local project, but yeah, also for structural integrity problems, we were not able to do so. So there are some real implications. However, what we see also with the 15 dwellings we built on site, and we use really modular construction principles, and these houses are really designed for that purpose, to take apart and to reuse it in another project. There you see it has a really positive environmental impact, and also that it's very cheap. Also to get this building, to take this building apart. So there is really, if you are not able to modularize and industrialize these technologies for upscaling and get them adopted in several projects, it's becoming very challenging.
Okay, and talking about modularity, there is also a question from Philippe. Can you elaborate what modularity exactly entails? You gave the example of the PV modules presented in one of your slides. They are individual systems or entities, but what makes it that you call them modular?
Yeah, it's actually the pictures maybe not the best picture, but it's actually it's a part of a roof system. It's connected to insulated panels and also included with dormer windows, and they can easily be adjusted to various types of roofs. And so these are actually part of the solar panels itself are part of a larger system in the same way as the other examples, but in the picture did not showcase the panels itself. Yeah, but that's not actually I don't think we should focus on this key example, but the opportunity for modularity in the sense of disassembly and reusing these materials repeatedly in order to lower the environmental impact.
All right, so let's move on then. Philippe has a suggestion to Pelle and Mikkel about that it's also necessary to re-educate building professionals. Do you have a reflection? Would you like to reflect on that?
Pelle or me?
Yeah, I can do that. I think that is definitely true. That I think this whole knowledge that we are talking about, this whole expertise and the lift and rise in complexity that needs to be dealt with has a number of problems that we couldn't really dive into here. But I think one of them is the problem of doing things simultaneously. Like now we have a very phase part way of construction. We start in, the abstract idea of the architectural idea, and then we end up in the more literal materials and detailing. And what we seem to notice these days is that if we really want to do tectonics of avoidance and get rid of all the unnecessary systems, we have to do everything at once. We have to be in 1 to 5 details and 1 to 1 in the materials, in the LCA analysis, while doing conceptual design. And that means that we also should know in-depth knowledge about, a lot of engineering as an architect, like how do we come about passive indoor regulation and what are all the systems in play and the interconnections and the synergies, good and bad. So I think in order to take on that complexity, we need professionals that know each other much better. And that, of course, means that we should be educated not just in our own profession, but a little bit in everyone else's as well, which is just really difficult to find out what way to do. And if we're talking about rising complexity, it means that we should spend more time in figuring out what to do, like each profession, but we also need to do what all the others are doing. So I think it's just, I would definitely agree that we have to think about how we do design and in completely different ways. And we also have to figure out ways to be better at talking our collective language of circular design and sustainability.
Yeah, you also gave the example of YouTubers and that we should not join the dark side. So how could that? Could you explain a little bit more what you meant with that?
Well, it was just to say that at one hand, it's very depressing that even though we can point towards some very promising solutions with tectonics of avoidance, we find no financial drivers for companies to invest in them. But there is perhaps ways to go around them. And one way was to become a turnkey contractor in which you, as a knowledge provider, actually also provide the end product. And that is what we call the dark side, because I guess a turnkey contractor is not something most architects would like to be. So that was one option. And the other option was to perhaps tap into that, even though you don't get a lot of money with giving away your information free, if you give it away to a lot of people, you might have a revenue from that. Just to say that there might be ways in which we can actually attract more investment in these kind of tectonic of avoidance solutions, rather than just investment in making products more advanced and more material consuming.
Okay, thank you. And the approach that you're advocating, the innovation of nothing, can it also, the examples you gave are from architecture, would this also apply to civil engineering, to infrastructure?
Yeah, I guess, and I think it's also related to the concept of frugal innovation, that you can actually strip down the function and see what's really necessary. So in general, I would assume yes, even though I don't have the examples at hand for your question.
I think there's also, there's this really difficult discussion that lies in this discussion is that is what do we find as enough for the function to work, basically, and here we have to ask questions about human well-being. Like now we are having the 24 degrees in all rooms all year round, even though there's no one in an office building at night and stuff like this, and then and over the winter break it just uses loads of energy. Like maybe we have to discuss the whole idea about how we understand well-being, and maybe we started off with the image of this highly mechanized knife for cutting meat, but do we really need that kind? Like that question could also drive, at least in architecture, to a much simpler and maybe more beautiful, maybe more refined idea about what human well-being means in architecture than just this 24 degrees. But to answer your questions, I don't know. But I think those kinds of questions could, we should ask them on all aspects of our life, I think. So I would guess that it would also apply.
All right. Okay. Thank you. So then I'm looking at the chat again. Waldo gave a suggestion to Philippe about modularity. So with a link where you could have a look at. There's also a question about the recordings. John, do you know about this? If the recordings are made available to everyone?
You can. I would ask the person who would drop this question to ask it in the help function. But I'm not sure about this about how this will be shared with you at this point.
All right. So that question needs to be asked to someone else. Then there's another question of Philippe. Asked to David. He says that's a great job in helping the local communities. And if you also looked at local organic materials instead of what you showed, rather than the two-part mix, which is probably fast to use but slower to supply due to transport, as you mentioned.
Yeah, thanks. And in some areas they do have like a palm frond that they weave together and they utilize it, but it's very limited areas that do have that particular material. So if there's material, they'll try and use it. Otherwise, they just sit and bake in the sun and get hot and get cold in winter.
All right. And David, in your abstract, you wrote that your project requires input from academia. So we have some people from academia here in this session. So what do you need with your projects?
Well, really good criticism has come. Had some great comments from Barrie and collaboration. I think that's really sort of where we need to go with this particular project. Instead of trying to think we've just got to stay on the academic route, because that seems to be a very difficult route. So yeah, thanks. I've got it already. Thank you.
All right. And then I see that Mikkel has another question to John about how you can further reduce the cost if you want to upscale further.
Yeah, what we did in the project in the final stage is we made prefab elements out of recycled concrete, and these elements are just designed in such a way that they can be disassembled after they are installed, and in that system is about 20% more expensive than if you do it in traditional concrete. So that's not that much if you take into account future value, and also if you are able to find the economic model that you also can include the environmental impact, the shadow cost, so to say. So actually, there is really potential, but of course it will always there's also a kind of extra value you add to the structure. So which in that sense always a little bit more expensive than traditional construction. But we believe it's about 120% compared to traditional construction.
All right.
And I just found out that the recordings will be it's available to look back at them later on.
Okay, excellent. So then, with that last announcement, I think we came to the end of our session, John.
Yeah.
I believe we handled all the questions in the chat. But if not, I'm sure that people can also ask the presenters the questions later on during this conference. So thank you, everyone. A special thanks to the people that were presenting their research projects over here. Thank you very much. Thank you to the audience for listening and also posing some questions. So we had very nice discussions, and we can now move back to the plenary part of this conference. So thank you again, and see you over there.
Thank you very much. Thank you.
Yes. Bye-bye.